Hey guys, how are you? Only a very few days are there for the examination. Hope you're preparing well for the examination. Apart from that, now we are entering into the summer season. It's a great summer for everyone, I think so. So what we have to do, always we have to keep the body hydrated. As a chemist, I know you should know that what is the meaning of hydration. So you have to drink a lot of water. Okay, that is the meaning of hydration. So along with the water, you add the juice of citrus fruits. Okay, so that will increase the water absorption in your body. So now, hope you are preparing well for the examination. Now I am adding one more flower to your crown. So I'm giving you one more trick for writing the electronic configuration in this session. Let's go to the session now. So what we are going to see, it's a simple trick to write the electronic configuration. So already I have told you that the electronic configuration for each and every element is like a Aadhaar card for each and every one in India. Okay, so while seeing the Aadhaar card, from the barcode of the Aadhaar card, we will get to know all the information about the person. So it's same thing. So if by seeing the electronic configuration, so we will come to know what is the electronic characteristics of the element. Okay, so for that we should know how to write the electronic configuration properly for each and every element. So we have studied in a textbook that we have to follow those this many principles. After that only we have to write the electronic configuration. So for that, so many students, they will be feeling that writing electronic configuration is very difficult. But I am going to give you a simple trick how to write the electronic configuration easily. So what is the simple trick, students? Let's go to the session now. See how to write the electronic configuration. Already we know. So while writing the electronic configuration, we have to follow the rules and regulations. The first one, the most important rule, is the half-bar rule. So the electrons are added progressively to the various orbitals in their order of increasing energies, starting with the order of lowest energy. So it should start with the lower energy orbital and it has to go to the successive energy levels. This is the first one of our principle. The second one is Pauli's exclusion principle. That no two electrons in an atom can have the same set of all the four quantum numbers. So what are all the four quantum numbers? The principal quantum number, azimuthal quantum number, magnetic and spin. So none of the two elements are having the same electronic configuration or having all the four set of same quantum numbers. Fine. A third one, Hund's rule. Pairing of electrons in the orbital does not take place until all the orbitals are singly occupied. You cannot pair the electrons in the p orbital and the d orbital until the orbitals does not take place until all the orbitals are singly occupied. Okay, so now I am going to give you the simple trick. What is the trick, students? Trick number 1. What is a simple trick? See, we know that how many electrons can occupy the s orbital? 2 electrons. How many electrons can occupy the p orbital? 6 electrons. How many electrons? 10 electrons for the d orbital and 14 electrons for the f orbitals. Okay, so now the trick is we have to write reverse order twice. Okay, so reverse twice, that is the trick. So what is the trick? How we are going to write? See, first we are taking the s. Yes. S. Next, then PS. 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 Next, DPS. 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 The next one is FDPS. 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 Okay, now how to fill the numbers. See, 1, 2, 3, 4. Fine. Now the remaining s orbitals, s energies, now you can fill it by the successive numbers. 1, 2, 3, 4, 5, 6, 7, 8. The next one is P. Only 2 is there. So 3, 4, 5, 6, 7. Next one is D. See, 3D is there. 4, 5, 6. Okay. Now see the F. 4F orbital here is here. And the next one is 5F. So by following this one, you will be feeling easy to write the electronic configuration. So examples also I will show you here. See here, the first one we are going to take is the nickel. So what is atomic number? The nickel is coming in the 21 to 30. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel. Nickel is 28. Okay, so we'll start writing it here. See, we know that only 2 electrons can occupy the s orbital. So 1s2, 2s2, 2p6, and then 3s2, 3p6, 4s2. Now you count 2 plus 4, 2 plus 2, 2, 4, 4 plus 6, 10, 12, 18, 20, 20, it is 28 it is. So only 8 electrons are more. So 8 electrons means next it will come as 3d8. Fine. This is the electronic configuration for the nickel. So next time we will go for the aluminium. Aluminium, where it is coming? It is coming in the 11 to 12. Sodium, magnesium, aluminium. Aluminium is 13. So we'll start writing the electronic configuration. 1s2, 2s2, 2p6. See, 10 is over, only 3 is remaining. 3s2, 3p1. This is the electronic configuration for the aluminium. So next we'll go for the chromium. So you have to be more careful writing these 3 electronic configuration. One is chromium, another one is copper, another one is palladium. So why, students? Why means, what is the atomic number of chromium, students? 1, scandium, titanium, vanadium, chromium. Chromium is 24. So while writing the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So 20 is over, remaining 4 is there. So according to the Aufbau principle, it has to come as a 4s2, 3d4. But instead of this one, so the electronic configuration it will change as 4s1, 3d5. Keep it in your mind. The electronic configuration of chromium it will change to 1s2, 2s2, 2s2, 2p6, 3s2, 3p6, 4s1, and then 3d5. Why? Because the 3d, that is d orbital, half-filled configuration is more stable than the other configurations, and half-filled and fully filled configuration is more stable as compared to the other electronic configuration. That is the reason it is pulling one electron from the s orbital, it is attaining the half-filled configuration. Okay, the next one is the same thing, the same principle we are following it for the copper. Copper atomic number is 29. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper. Copper is 29. While writing the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9 it will come. So instead of the 3d9, it will change as 4s1, 3d10. So fully filled configuration is more stable. Okay, the same electronic configuration. So instead of the 4s2, 3d9, it will change as a 4s2, 3d10. Okay, the next one is palladium. Palladium atomic number is 46. So while writing the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, and then 3d10. Okay, 4s2, 3d10. Now 10, 20, 30 is over. Then 4p6, and then 5s2. The remaining, how much it is there? 30, 36, only 6 is there. So 5s2, 4d, how much it will come? 4d, so what it will come? 4d8. But instead of this 5s2, 4d8, this electronic configuration it will change as, how it will change? So it will take the 2 electrons from the s orbital and it will attain the fully filled configuration. So instead of 5s2 4d8, it will change as a 4d10. Okay. So you have to be more careful writing the electronic configuration of chromium, copper and palladium. Only these three, it will not follow the Aufbau principle and it will change according to the stability. Fine. So if the atomic number is so simple, means it will be easy to write the electronic configuration while following only this rule. Okay. If the atomic number is more than 40, see how many lines we are writing it here. So instead of writing these many lines, I will give you one more trick to write the electronic configuration so simply. So what is the trick, students, that we are going to see now? Trick number 2. So what is the trick? So we have known that how many groups are there in the periodic table? 18 groups. So 18th group is a noble gas noble gas. Fine. So what are all the elements are there in the noble gas? You just start memorizing the noble gas group. So what are all the elements are there? Helium, neon, argon, krypton, xenon, radon, oganesson. So we can leave the oganesson because still the study is not yet over. Fine. Now only this much is enough. Fine. So if you are feeling difficulty to memorize this one, I have given you the simple trick how to memorize a noble gas. It is all the group elements in a separate video. You can go through the video. Okay. See. He never argued about creepy excellent reindeer. So if you for memorizing this one, it will be easy for you to memorize the group elements. Fine. Now, so what is the trick? So we wrote the group elements of noble gas: helium, neon, argon, krypton, xenon and radon. Fine. So we know how many elements are there in each and every group. So how many elements are there in each and every group? The first group, it is having the 2 elements. Second group is 8. Third group is 8. Third period is 8. So we know how many elements are there in each and every period, that we have to write it in the left hand side. See how many elements are there in the first period? 2. Second period it is 8. Third period is just 8. And fourth one is 18. And then 18, 32 and then 32. Fine. Now right hand side, what we are going to write? The atomic number. It will help you to write the electronic configurations of other elements easily. So how to write? See, the first one atomic number is, we know that in the first period only 2 elements are there. Atomic number of helium will be 2. The second one, so you have to addition in the cross side. 2 plus 8 it is 10. 10 plus 8 it is 18. 18 plus 18 it is 36. 36 plus 18 it is 54. And 54 plus 32 it is 86. 86 plus 32 it is 118. See the periodic table itself, it is over. Now, so we can apply this trick to in these elements. We will see the examples. The first one is the zinc. What is the atomic number of zinc? It is 31. You just see what is the nearest noble gas configuration. So where it is coming in between the two elements of the noble gas. 30 is in between argon and krypton. Okay, so you write the atomic number of argon. You can write it in the square bracket. Argon. So 30 minus 18, how much it is? 12. So only 12 we have to write it here. So next, which group, which orbital we have to take? So which principal quantum number we have to take? That will be the doubt. Okay, so how to rectify that one? So argon we wrote, right? See, so argon is over, means the principal quantum number 1, 2 and 3 is over. So next you have to start with the 4. Okay, so next you have to start with the 4s2. So how much is remaining? 12 means 3d10. See, now the electronic configuration is so simple. So you will not feel the difficulty to write the electronic configuration also. So now we'll see the next example. The next one is a 42 molybdenum. Okay, so now we'll see the trick number 2. 42 is coming in between krypton and xenon. Krypton and xenon. So we'll write the krypton in the square bracket. Krypton in the square bracket. So 42 minus 36, it is remaining is only 6. So how many principal quantum number is over? 1, 2, 3, 4. So 4 is over. The next one you have to write it as 5s2 4d4. So already we have seen that the d orbital, if it is alpha half-filled configuration, means it will be more stable as compared to the other configurations. So it will change as a krypton 5s1 4d5. Okay, I think it will be easy for you to write the electronic configuration. So if you want to try this one, you just pause the video and you can try it, and then you check the answer, that the answer is correct or not. Okay, now next one is the barium. Barium atomic number is 56. So where it is coming here, see, xenon and radon. So we'll write the xenon in the square bracket, and 56 minus 54, that is equal to 2. So how many principal quantum numbers are over? 1, 2, 3, 4, 5. So next only 6s2. Okay, the next one is the tellurium. Tellurium atomic number is 52. So 52, where it is coming? See, 36 and xenon. Okay, so what we have to write it here? Krypton. So write the krypton in the square bracket. Now how many principal quantum numbers are over? 4 is over. So next it should start with the 5. So remaining atomic number is 52 minus 36. 16 is remaining. So 5s2 4d10 and then 5p4. You understood, students? You just try it. So keep practicing. Without practice it will not come. So once you go to once or twice, 3 times, if you are practicing, the third time definitely you can write the electronic configuration easily. So you can try this one as a practice yourself question also. Okay, so otherwise I will give you the answer after writing the electronic configuration. You can check it. Holmium atomic number is 67. Atomic number is 67. Where it is coming? See, the holmium atomic number is 67. So it is coming in between 57 and 81. What is the 57 and 81, students? It is the lanthanide configuration elements. It is there in between the 57 and 81. Okay, so definitely the last valence electron, it will enter into the shell of that is f orbital. Fine. Now we will start writing the electronic configuration. The 67 is coming in between xenon and radon. So definitely the xenon, it has to be in the square bracket. Okay, after the xenon, so how many principal quantum numbers are over? 1, 2, 3, 4, 5 is over. So next one, it has to start with a 6s2. So 67 minus 54, how much it is? 13. So 6s2, so 2 is over, 11. So 4f11 is the electronic configuration for the holmium. The next one is the fermium. The fermium is 100. The electronic configuration, where it is coming in between radon and oganesson. So you have to write radon in the square bracket. So the principal quantum number 1, 2, 3, 4, 5, 6 is over. So it should start with the 7s2. So 100 minus 86. 100 minus 86 is 4. And then it is 1, 14. So 7s2, 5f12. Okay, so it is coming in with the actinides. Next one is cesium. Fine. The next one is the cesium. The cesium atomic number is 55. The 55 is coming between the xenon and the radon. So we have to write xenon in the square bracket. Next it has to start with 1, 2, 3, 4, 5 is over, 6s. Okay, so how much is remaining? 55 minus 54. So 1 is the remaining. So it will be end up with 6s1. So it is belonging to the s block elements. The next one is argon. It's a simple atomic number. It is 18. So 18 is coming in between. That is, what is it? It is the electronic configuration, this atomic number of the argon. So how we can write the electronic configuration of argon now? So we have to take the neon as the nearest to noble gas configuration. So neon, it should be in the square bracket. Now we'll start writing it. So 18 minus 10 equal to 8. So two principal quantum numbers are over. So 3s2 3p6 is the electronic configuration for the argon. Okay, so you practice. The practice only, it will make you perfect in writing the electronic configuration. So after practicing, so you can go the practice for the practice yourself questions also. It is given in the separate video. So by seeing that, you will come to know. So for example, I will give you the questions here. You can check it out. Test yourself questions or practice yourself question. You start writing the electronic configuration for the 13th group elements, 17th group elements, and the second group elements. So it is given in the Roman letter 2. So according to that you can write. Fine. Thank you for watching the video. This is the first time if you are seeing the video. Please subscribe the channel. You press the bell icon to see the further videos, to educate yourself. Okay, bye. Stay tuned. Bye.